Alright, so this video is going to try and show that the order in which you do transformations is important. So basically, if I look at this example of y equals 1, I'm going to do a dilation first by a factor of 3 from the x-axis, just going away from the x-axis, and then a translation of 2 units in the positive direction of the y-axis. So what happens to every single xy coordinate in that case, alright? So if that's the coordinate 1, 1, dilation by a factor of 3 would go to 1, 3, and then 2 units up would go up to 1, 5. Okay, so what's happened is every single xy coordinate, x stays the same, but y has been multiplied by 3 first, and then you add 2. So this line y equals 5 becomes y equals 3, and then y equals 5 with those transformations. And so you look at it symbolically as, okay, first what's happened is I've multiplied every single y coordinate by 3, and then after I've done that, I've added 2. Okay, so in this sequence of transformations, y is 1 is mapped to the image y equals 5. But if I compare it to, translating 2 units first up and then dilating by a factor of 3, what happens is, well, y equals 1, if you translate that up 2 units, you go y equals 3. And then if you multiply that by a factor of 3 away from the x-axis, you get y equals 9. Okay, so in this sequence of transformations, y equals 1 is mapped to the image of y equals 9. So the order of operations is important. See, first, what's happened is you've added 2 first, and then you've multiplied, so you need to put brackets in there. So again, if you substitute in y as 1 here, you get 1 plus 2 is 3 times 3 gives you 9. And that's the purpose of that task, is just to think about the sequence of transformations and how the order is important. And you need to be able to read this sort of symbolic notation.